Professor Mandar Dikshit from Electrical Engineering Department. Today we will study series and parallel circuit through some examples. First we will take example for parallel circuit. The example states that determine the currents through and the voltage across three resistances of ohmic values 5 ohm, 10 ohm, 20 ohm are connected in parallel across a 100-volt source. Also find the current and power drawn from the source. So this is the example used for parallel circuit analysis. Now let us see how to solve this example. Now let us draw the circuit diagram. Let denote the resistors as R1 equal to 5 ohm, R2 equal to 10 ohm and R3 equal to 20 ohm. Also, the supply voltage is given as 100 volt and the current flowing through the whole circuit will be denoted as I. As this circuit is a parallel circuit, the total current will be divided into number of paths. Let the current through 5 ohm be denoted as I1 and similarly current through 10 ohm resistors is denoted by I2 and the current through 20 ohm resistance is denoted by I3. Now as the resistances are connected in parallel, the total voltage across every resistor will be same and is equal to source voltage, that is 100 volt. Hence, applying Ohm's law, we can calculate current I1, I2 and I3. Current I1 can be calculated as I1 equal to V divided by R1, where V is the supply voltage which is 100 volt and R1 is the resistance through which current I1 is flowing. The value of R1 is 5. So by substituting the values of V and R1, we can calculate I1 as 20 ampere. Similarly, as we know that the voltage across R2 is also 100 volt and the value of resistance R2 is 10 ohm. Therefore, I2 will be given by V divided by R, where V is again supply voltage, that is 100 volt, and R2 is resistance 10 ohm. Therefore, 100 divided by 10, that is 10 ampere. So my value of I2 is 10 ampere. Then I will go for I3. So I3 is the current flowing through R3, which is having value of 20 ohm. The voltage across R3 is same, that is supply voltage 100 ohm. So formula for I3 is V divided by R3. The value of V is 100. The value of R3 is 20. Therefore, the current I3 is 5 amp. So we have calculated I1, I2 and I3. I1 is 20 ampere, I2 is 10 ampere and I3 is 5 ampere. Now we will go to calculate current from the source, that is total current flowing through the source. It can be calculated as total current I is equal to I1 plus I2 plus I3, that is I is equal to I1 plus I2 plus I3. Now to understand this, let us denote this junction as A. So at A we can apply Kirchhoff's current law. According to Kirchhoff's current law, total current incoming or total current going towards the junction is equal to total current outgoing from the junction. Now at A, total current which is going towards the junction is I, and total current going away from the junction is I1, I2 and I3. Hence total current will be I1 plus I2 plus I3. Therefore, total current equation is I is equal to I1 plus I2 plus I3. Now substitute the values of I1, I2 and I3. We get I is equal to I1 is 20 ampere, I2 is 10 ampere and I3 is 5 ampere. So total I is 35 ampere. Hence my total current flowing through the circuit I is 35 ampere. Now next part in the question is to calculate power drawn from the source. The formula for power drawn from the source is given by P, that is power, is equal to V multiplied by I, where V is total voltage or source voltage and I is my total current. If you substitute the values of V and I, we will get the power. The total voltage is 100 volt and total current just we have calculated as 35 ampere. 100 multiplied by 35, that is 3500 watt. Watt is the unit of power. Hence, power drawn from the circuit is 3500 watt. Thank you for watching this video.